So this is how you solder up an SPRacingF3 NEO and its companion VTX OSD board. So the most important thing to notice at the moment is that on the NEO board there is a connector here, and on the OSD VTX board there's the corresponding connector here, which has the pins on it. In the VTX box there are a bunch of little connectors here. So what we're going to be doing is soldering these ones, the pins in the VTX board and the sockets in the NEO board. But what we want to do to make our lives a bit easier, and also so that when the boards are joined together they are as close as they can possibly be, we connect these into these before we solder them all up. So these are directional. So if you can see on here, there is one end here which doesn't have much metal on the bottom of this, and if you flip it over you can see there's a lot more metal there. That end is the end that you do not solder, and that end goes into the little connectors, so that you have the end with the least metal here, and also on the other side it looks the same. Once you've got that like that, insert one of these pin end. So I'm just going to show you the orientation again. So the pins go in here with the metal bits, large metal surface area going up, and then the connector on top. And these are slightly different colour as well. These are more silvery and the other bits are gold, so it's easy to check that you've got them the right way around. I'm going to do the remaining. And the next one. And the next one. There. Okay. The next thing to do is then to bring this onto this. It can be a little bit tricky, but the goal is to align this with that. The two connectors, that's what we're trying to do. So I normally start with putting those in and those in. And then you see here it's one pin out. That is incorrect. So we need to make it. This is the only fiddly bit of the entire process as well, just if you're wondering. It is a little bit fiddly, but it is the best way of doing it. So we'll try again. And you want to bring the top onto the bottom as straight as you can. Then I normally use a pair of tweezers to just put those into the right place. There. So before pressing it together you need to check that the connector in the middle, I'm going to point to it with the tweezers, that the connector in the middle here, that all of those 12 pins are correct. So look at it from one end and make sure the pins aren't sticking over one side or the other side, and then look at it from the side and make sure the pins aren't sticking over the front or the back. Once you're happy with them like that, press it together. That will then stay connected even if you shake it about a little bit. So now we need to solder in the stacking connectors to the two boards. And while we're soldering, ideally we want to press the boards together a little bit whilst we're soldering. So you can either push it down and then solder it, or you can clamp it and solder it that way. The reason you want to do that is because you want to get both of the boards as close together as possible. So I normally start with the OSD side, which we're now going to do. So So to do this, we've got soldering iron and solder, and on the board you'll see that there's square connectors and round connectors. The square connectors are generally ground, 3 of them are ground I think, from memory, and they're slightly harder to solder. So if you do the circle connectors first, it'll warm the board up next to them. So if you remember, I said I was going to press down while soldering it. This is how you do that. So tin the soldering iron, heat it up, apply some solder, let it flow. Done. And then we're going to do the opposite corner. Let it flow. Then we're going to do one next to it. And we're going to go back round and finish this one off. Then we're going to do the remaining ones. Start with a circle. Let it flow and remove. Let it flow and remove. And each time I'm pressing down on the board on the top. And you should end up with nice shiny solder joints like that. Now we do the bottom ones. Now the bottom ones should only just be poking through the PCB, because the PCB is thicker than the top one. So we're going to do the same again. So we're going to solder the circles first. Now, important bit about this, there's more components on the bottom board that might be in the way of your soldering iron. So align your board so that it's not near any of the components. So you could go across from this direction, but then the soldering iron would be near some of the other components. So if you align it so that it's not, that's going to be better for you and easier. Less chance of you making a mistake. And again, we're going to press down on the board. So we're going to solder up. And you can see this one is slightly harder to flow because it's connected to the ground. But make sure it's properly soldered. Then we're going to do the opposite corner. And let it flow. And each time my soldering iron is coming from the edge and not going over the components. And this is the slightly harder one to solder. There. The reason that's harder to solder is because it's connected to the ground signal. And the ground signal goes quite far around the board and basically sucks all the heat out of the soldering iron. It acts as a giant heat sink. And there we go. So that is the main part of soldering the two boards together. To separate the two boards, which you may need to do for various different reasons, such as setting the voltage select jumpers and also soldering in the connectors. Don't pull it off from like a corner, because what you'll do is just bend all the pins. So put equal pressure all around the board and prise it off, and it should come apart. And that will also, because we soldered all these together, it'll also help locate everything for when you're reconnecting it. So we could have just soldered these into here, and these into here, and these into here, and these into here, and then soldered these into here, and these into here, and this into here, and this into here. And then when we tried to plug it together, what we'd find, it wouldn't be quite aligned due to the size of the holes and the size of the connectors and the placement of the connector. By soldering the assemblies, as in this bit and this bit, together into both boards, what we're doing, we're making sure that the bottom parts are exactly aligned with all the top parts in relation to these connectors. That's one of the key bits. So to reconnect, you should be able to very simply now just put the pins in the holes, but before you press it together, just check that the connector in the middle is aligned correctly here. See, the pins are correct. What you don't want to do is have it just off to one side and try and push it together, or just forwards or just backwards. Just make sure that it's aligned from the front, and then look at it from the side and make sure it's aligned there, and then press together evenly. So that's how you solder the stack. Other things to solder on the board are the voltage select jumpers for the camera, and also the 3S 4S selector. So on the bottom of the board, next to the LC filter parts, there's a selector here. If you want to use the 12 volt regulator, which is this component here, you solder the two pads on the left hand side. If you're using 3S batteries only, and you're using a 12 volt external VTX, or other 12 volt devices, and you want to use, then you will need the battery voltage to power those 12 volt devices, in which case you won't be using the 12 volt regulator, because what would happen is your almost or just over 12 volts from your 3S battery would then be reduced down to about 9.6 volts or something like that, which probably wouldn't be sufficient to power your 12 volt devices. So then you would not use the 12 volt regulator, and the battery voltage would then be going directly to your external devices. As it is, as these two parts are, you don't even need to use the 12 volt regulator. It's only if you're using external VTX, if you buy this one without the VTX module, that you may need to use the 12 volts. So if you're not using any 12 volt devices, just leave this as it is, just leave it alone. If you are using a 12 volt device, then bridge either one side or the other side. Here I'm going to just demonstrate how to bridge it to use the 12 volt regulator. So you basically start by applying a little bit of solder onto one pad, and then a little bit of solder onto the next pad, and then letting it cool for a moment, and then add a little bit more between the two pads and letting it flow. And then you end up with a nice shiny joint which covers both of the pads. So you connect one square pad to one triangle pad. Do not bridge all three pads together, otherwise you'll blow things up and it'll be bad. The camera and VTX power for external VTXs works the same way. So if you're using a 12 volt camera, then you get the OSD board and you do the same thing. So bit of solder on the middle one, bit of solder on the 12 volt pad, and then bridge the two together. It's as simple as that. If you're using an external VTX, which we're not in this case, then you can select either 12 volts or 5 volts for the external VTX connection. The external VTX connection are these three pins here. The only pin that changes is the center pin, and that either changes between 12 volts and 5 volts. And it's the same with the camera. This selector only changes the voltage on the center pin here. If you wanted to attach your VTX using the pads, for instance, then you could just use the 12 volt or the 5 volt on the ground pads, depending on which ones you wanted to use. And the VTX selector would make no difference at all. So since this has got a VTX module on it already, we don't need to use an external VTX, we just need to use a camera. The board is marked with cam and VTX, so we're going to connect one of these connectors. that's basically going to go in there. And then we're going to solder it up. Again, bring the soldering iron in from the edge of the board and not over the board. And we want to press down a little bit on the board as we do it. And there we are. That's then soldered in. So then you can attach your camera using the cable supplied. Okay. Connector supplied. Additionally, what else we got in here? We have the antenna connector. So if you're using the pigtail cable, which is this cable, which is slightly longer on the ones that come in the boxes, that basically goes over the top here and presses down like so. When you're joining these two together after attaching the pigtail cable, just make sure that you don't get the pigtail cable trapped on any of the stacking connectors, like this for instance, when you plug it together. Okay. Another way of attaching an antenna is to use an RP SMA connector, which my lovely assistant hadn't got out for me.
Don't make me laugh.
So what we're going to do is try really quickly and find one. Please excuse the pause and just bask in the glory of the Neo. Let's see, where is one? Here's one. Okay. Right, we have one. Right. So this is a jack connector. This is a PCB mount jack connector. Now the Neo OSD board is designed so that you can either use the UFL connector here, or you can use one of these. So if you want to attach the antenna directly, you can solder it like this. You put that on the edge of the board. I'm not going to solder this one up because I don't want it on there. But basically, there are 3 pads on the top, which go with 3 pins on the connector here on the top. And if you flip the board over, you will see that the little connector underneath sits in the middle of that, and you solder the 2 legs either side of the connector, and that is how you attach one of those. Both of these connectors do the same thing, just this is more convenient for most people. So if you break your UFL cable or your pigtail, then you can get one of these connectors if you're in a hurry and attach one of those on. So you get a second life with the board. I'll just re-demonstrate how to attach this. Once you've soldered it, you basically just pop the pins in, check that it's not misaligned, and squish it together.